Hey guys, welcome to the first lecture video for Chem 115. Now, the goal for this semester is to better understand what happens during a chemical reaction through the lens of kinetics, equilibrium, and thermodynamics, to name a few. Now, in the first semester of general chemistry, you guys learned how to write and balance a chemical equation such as this. And in the first semester of general chemistry, you guys used or utilized this balanced chemical equation to perform stoichiometry, determining how much product can be produced per given amount of reactants. Unfortunately, the range of information that this balanced chemical equation conveys to the reader is very limited. And so unfortunately, it does not describe the entirety of a chemical reaction, of what goes on in a chemical reaction. For example, it doesn't tell you whether or not the reaction is spontaneous or non-spontaneous. It does not tell you how fast or slow the reaction is occurring. And it does not tell you how much product or reactant will remain at equilibrium. And so writing this balanced chemical equation only informs the reader what reactants are involved and what products are produced. And so it is these types of topics that we're going to cover and address throughout this semester. So to kick things off, the first chapter that we're going to cover is kinetics. And so kinetics is the study of the rate at which chemical processes are occurring. Another way for us to better understand what kinetics is studying how fast or how slow a chemical reaction is occurring. And by understanding the rate at which certain steps in the chemical process is occurring, kinetics can help us understand the mechanism of a chemical reaction or reaction mechanism. And so the mechanism of a chemical reaction provides greater detail than what a balanced chemical equation can give us. This is only describing a summary of what's happening. It's not telling us how these ions and how these oxygen molecules are coming together to form iron 3 oxide. Now, there's many reasons for us to study kinetics. One of it is understanding the reaction mechanism. But in a more global and industrial level, studying kinetics can help us understand the practicality of making certain drugs, whether or not it's feasible to be done in certain timescales. And so by understanding the rate limiting step and understanding the rate of the reactions, one can basically improve upon the steps of synthesis to produce a viable drug in a shorter amount of time and in large quantities. Unfortunately, this course is not committed to the study of pharmacokinetics. Rather, we will only study the general theories of kinetics, such as reaction rates, understanding the relationship between the rate of the reaction and concentration through rate laws, understanding the relationship between concentration and time using integrated rate laws and half-lives, looking at the chemical reaction under collision theory and viewing that same perspective using a potential energy diagram. We'll also learn and talk about activation energy and how the rate of the chemical reaction is dependent on temperature and catalysts. And we'll be able to quantify it using the Arrhenius equation. So last but not least, in this chapter, we are going to learn about reaction mechanisms. We'll learn what they are, what they look like, how to determine if it's a plausible mechanism or not, and how to write rate laws from proposed reaction mechanisms. And so the first thing that we want to do is lay the foundation for this chapter. And to do so, we need to be able to define, and we need to be able to somehow come up with a way to calculate the rate of reaction.